that you can hear my voice clearly. Again, I'm sorry for coming to the class late. Fortunately, things are well, a little bit okay now, so I can leave my kid and join the class. Okay, so I will share to you the material for today so that you can follow along with what we are going to study today, okay? Let me see. Right. Okay, so the file is sending right now. Let me know if I'll let you know if it has finished loading at least. Okay, so on the last part of our lecture, we're going to take an attendance by opening all the videos. So I hope you'll be prepared for the end of the lesson. Did you see the file? Did you get the file?
Yes, ma'am.
Okay, all good. Okay, let's start the class then. All right, so I've shared my screen. Let me know if you can see my screen now. Can you see my screen?
Yes, we can, Miss.
Okay, thank you for confirming. And I hope you can also be active during the class. So if there's anything that you would like to confirm or you want to ask further during the lecture, please do so by opening your microphone, okay? So today we're going to continue our material lecture about parts of the predictive and prescriptive analytics. We are going to talk about time series analysis in this week. Let's start with a question. Imagine you have built a successful business and it has been running for 5 years. You finally hit the 5 years mark. You're no longer a small UMKM, but now you are great business. You have expanded your business and now you have the data for the past 5 years. So you would want to ask yourself, if I have sales data from the past 5 years, what insight can I gain from its patterns over time? So imagine you are looking at a sales data from the past 5 years. You have the sales data every day and you have it aggregated for monthly and also yearly. And then you might see some patterns there. So here, for example, we have this kind of graph from 1990 to 2016 about a time series seasonality. This is the US retail sales, billions of USD. So this is the y-axis is the number of sales, and the x-axis is time in this term year. And in the second chart, we have quarterly e-commerce sales as a share of total retail sales in the United States from 2010 until 2024. And then for the y-axis, we have 0% to 20%. So it says that in the fourth quarter of 2023, the sales hit 17.1%. So what does it mean for the business? What does it mean for the economy? This is the question that we would like to find what the answer is by doing the time series analysis. For example, the next example, this is a graph of monthly sales in 5 years that we were talking about earlier. And so here we have the month from month 0 to month 60. Remember, because we're talking about 5 years data, right? So 5 years means 60 months over time. And then this is the sales, for example, maybe in million rupiahs. And you can see that over 5 years, over the course of 5 years, there seemed to be some kind of pattern. In some months, the sales would peak and then it would decline, and then it would peak again, and then decline again, and then the graph is moving upward. We can observe here that there is a gradual upward trend. The sales is increasing every year. There is also a seasonal pattern, which is recurring fluctuations every 12 months, which is every year. And there is also some noise, random variations or unexpected shocks. We could observe all of these trends, patterns from this single graphic. So let's talk about what is time series data patterns. Time series data is a sequence of observation measured over a specific period of time at consistent intervals. So in general, time series data refers to data consisting of an indicator or variable that describes the characteristics of an entity across multiple time periods. For example, we can have time series data in terms of daily data or monthly data, quarterly or yearly observation. So we usually do the representation of the time series data like this. So this is xt, where t is 1, 2, and so the t means time. The time could be yearly, daily, monthly, quarterly, anything that we need to do the analysis. Now, why is it important to understand time series components? First, we would like to understand some patterns from data. We want to understand if there's any trends, seasonality, cycles, because we want to interpret the behavior. From here, we move on to forecasting, because we are talking about data analytics here, which is prediction and prescription. Predictions becomes more accurate when patterns are properly considered. And then the last one, we want this time series data to support our business decision. So we can have more effective strategy based on data insight. For example, we have this kind of original data that we saw earlier, the 5 years data, or maybe 2 years, 3 years data. From here, we can identify some trends, some seasonal, some seasonality, some cyclical, and then also some irregular noise within the data. For example, seasonal pattern is something like when ice cream sales rise every dry season or every summer. Trend looks like increasing sales or decreasing sales every year. And there's also irregularity or noise where sales drop drastically during a pandemic. So pandemic is something that doesn't happen every year. It happens maybe once every 100 years, they said. So this is an irregularity in our data. Let's look at the basic components in time series data. There are trends, seasonal, cycle, and noise. Trend usually tells us how the market growth could be in the future. Seasonal, usually about predictability of the demand every season. The same pattern usually will occur. Cycle, this is more about long-term movements, what economy, how the economy moves. And noise, this is about risk. If we think about trends, we want to notice whether there are long-term upwards or downward movement. For example, we have sales increase every year, driven by market growth, and this is indicating business direction, and we can use it for long-term strategy. For example, expansion, investment, budgeting, things like that. Seasonality is different. This is a regular repeating patterns over fixed periods. For example, during holidays, sales of certain products will rise. Sales of certain tourism attractions probably will rise. Christmas, year-end season, those are the seasonal time frame that we are talking about here. This seasonal trend is helping us to support operational planning based on calendar patterns. For example, things about inventory, promotions, staffing. During those peak seasons, they're going to be different. The next, about cycle. This is a long-term movement related to economic cycles. For example, property sales rise during economic booms and decline in recessions. Right now, we are facing with probably some people would say it is a cycle, but a very, very long one. It could also be a noise, random fluctuation about the war and how it affects everything else in the world economically. So if we can identify the cycle, we can understand our business position in the economic cycle and the macroeconomic risk. Last one is what noise. This is risk. This is a random fluctuation caused by unexpected events, such as what we are having right now. Pandemics, natural disasters, policy changes, war. And this indicates external risks, requires mitigation and contingency planning. So if we understand the patterns, we can understand the story behind the data, which leads to better and more accurate decision. Again, we want to be able to decompose the original data from several components, like for example, trend, seasonal, noise, cycle. We want to distinguish long-term movement, recurring seasonal effects, and random disturbances. So for example, here, from this kind of graph, we can identify some irregular fluctuations, some cyclical movements, some trends, and some seasonal cycles within the time periods. The key points here is we want to model the time series data without by considering the component, because if we don't understand the components, it will produce misleading analytical results. So if we incorrectly identify cycles or irregular fluctuations or seasonal trends, it may lead to poor forecasting and incorrect strategic decisions. Now, let's see. If we look at any graph and we see some kind of upward trend data, There might be a question, is upward data always good? But the answer is not necessarily, because we want to make sure that the increase comes from a true trend, not just a seasonality or temporary factors. Like for example, if we compare these two graphs, this one on the left is great because it looks consistent. The increase is consistent each year. But the one on the right, we see only increase during certain periods during holiday. So this is not growth. This is an increase due to seasonality. So the strategy for these two condition is different. One is to expand, invest, develop products. The other is to focus on seasonal preparation, not a permanent expansion. So here we see that we always want to analyze the pattern before making a decision. Does the increase occur in every period? Is there a repeating pattern? Are there external factors that influence it? What happens outside the observed period? So we want to ask ourselves all of these questions regarding our data before we make a business decision out of it. Let's look at another example. This is a monthly sales data over a 2 years period. And we want to be able to understand what is the main sales pattern. Is this a trend or a seasonal? What business decision should we make? And we want to focus on patterns, not just a number. Let's see. On May, there is a holiday, an Eid holiday. There is a seasonal spike detected. Christmas, year end. This is also a spike here in the sales. And we can see that outside seasonal periods, sales remain relatively stable. So we can see from this graph that this increase in sales is not due to a long-term trend, but because of a seasonal patterns. So here, the correct strategy is for preparing for the seasonal periods. And don't be doing something like over expansion, because this is not, we do not detect any increase in trend, but only for in seasonal periods. Okay, so the next important point is to identify what is a seasonality and what is a cycle. Like we have seen before, seasonality is more like regular and periodic repeating patterns, and it occurs at fixed intervals, like for example, monthly or quarterly or yearly, it will repeat. For example, sales increase during a Christmas or year-end period. While cycle is long-term fluctuations related to broader economic condition, and the intervals are irregular. It is not fixed each year. For example, business cycles such as expansion, recession, and recovery. This is the example of a cycle. So now I want to ask you the question. If sales always increase every December, is this a seasonality or a cycle? And if sales decline during a global economic crisis, is this a seasonality or a cycle? Let's see. Does anyone want to volunteer to answer the question? Well, I wait for you to answer. Okay. Okay. Um, can you still see my screen?
Yes, Miss.
Okay. I was trying to find a setting, but where is it? Okay. Maitza? Maitza, are you here?
Yeah, yes, Miss.
Okay, can you answer the first question? The one here. If sales always increase every December, is that a seasonality or a cycle?
I would say it's seasonality because it has patterns.
Okay. Okay, thank you, Maitza. We will ask next, Ravindra.
Yes, Miss.
Okay, what do you think about the second question? If sales decline during a global economic crisis, is that seasonality or a cycle?
I think it's seasonality, Miss. I think when during a global decline, usually the people, the rate of people who want to buy the things that they need for their household is going to decrease.
Okay, so you think it is a seasonality?
Yes.
Okay, thank you, Ravindra. Let's ask someone else. Trifiko Putra, are you here?
Yes, Miss.
How
I'm
can I
here.
call you?
Fico, Miss.
Fico. Okay, what do you think, Fico? Is a global economics crisis a seasonality or a cycle?
For the second case, I think it's a cycle, Miss, because it's depend on the economic condition, and it doesn't happen regularly.
Okay, yeah. Thank you, Fico. So, again, how we define, how we can see if something, if a decrease or an increase in sales is a seasonality or a cycle, we should think of the regularity, whether the pattern happens every year or every month, every the same month over and over again, or whether it happens once in like 10 years or like 20 years, right? Because a global economic crisis should not happen every year, right? For example, a global economic crisis, right now we are going to enter one. It looks like it's gonna be a big one. We don't know when we will recover. We don't know what kind of world is waiting for us at the end of the economic crisis right now. But before this, Indonesia also had economic crisis, but it is local to Indonesia. Other global economic crisis, we are talking about the world, probably during the war before this, World War One, World War Two. Those are the big happening, and it doesn't happen regularly. All we can do is to prepare the best that we can for the next crisis. So this is a cycle. Okay. For the illustration. This is the seasonality, seasonal pattern, regular and periodic repeating pattern. This one is cycle, cyclical pattern, long-term fluctuation, irregular interval. So seasonality is calendar-based, basically. Cycle is just the broader economic movement with uncertain timing. So this is the difference between seasonality and cycle. And it's very interesting to understand that this happening, whether it is regional or nationally in our country or globally in the world, it will affect our business. It will affect some of the business more than the others. And it will be reflected in the data, in the patterns. So this is why the time series analysis is very interesting and also very useful, because we can see the effect of the happenings in the world and also around us in the data, whether it affects our business or not, and how we can prepare for the future when similar things happen. Okay, next question. When analyzing sales data, which one is more important? Long-term trends or seasonal patterns? Which one do we want to pay attention to? Is it the long-term or is it the seasonal, the short-term? What do you think? Well, here's the answer. Where's the answer? I want to hear your answer, whether it's long-term trends or seasonal patterns. What do you think, Faiz? There are some people with no, they don't have names. I'm a bit confused. Faiz, are you here? Faiz Ramadan? Ahmad? Is there two Faiz in this class?
Yes, Miss.
Oh, only one. Okay. What do you think, Faiz? Which one is more important? Is it long-term trends? Is it seasonal patterns?
I
In
think
Europe,
it's more
yeah.
for the long-term trends
Mm-hmm.
because when analyzing data, it's more to the direction of the business.
Okay.
It
So you're
shows whether the
concerned.
sales are going planning and so
Mm,
on.
mm.
It helps with strategy and forecasting also.
I see. Okay. So long-term trends for forecasting, for making a strategy for the business, whether it's expanding or other things, making new products and stuff. Long-term trends is useful. Yes, I agree. But how about seasonal patterns? Um, Elwin? Hello, Elwin.
Yes, Miss.
What do you think about seasonal patterns? Is it important?
I think seasonal pattern is important too, because um, there are some season like Idul Fitri or Christmas that might affect stock.
Hmm. Yeah, yeah. Elwin is right, and Faiz is also right. One is important for long-term planning. Another is important for short-term planning, and both are as important, equally important. If we only focus on long-term trends and we do not, or we fail to identify seasonal patterns, then we will lose potential sales probably when the peak season comes and we are not prepared for it. Imagine. And of course, it will in turn affects the long-term trends as well, right? Because we want to be able to do the growth to increase our graph over time by doing better and better in the seasonal patterns. That's one of the things that we can aim for, right? So incremental increase, and it will result in better graph over time. The increased trends, which is not just seasonal but overall an increase. This is what we want to aim for. So yes, both are important for different business decision, but both are also related to each other. Okay, let's look at the time series data pattern decomposition now. So what is a decomposition? We have talked before that time series data is a mixture of trends, cycles, seasonality, and also random shocks, random happenings, noises. And without decomposition, it would be difficult to identify the true underlying patterns. That's why a decomposition in time series analysis is important to separate the components because it will help us making analysis clearer and more accurate. We want to be able to distinguish long-term behavior from short-term fluctuations. We want to improve our forecasting accuracy, whether it is short-term or long-term, and we also want to reduce the risk of misinterpretation. That's why we do decomposition in time series analysis. We want to analyze differently between the trend and the seasonal components because one is for long-term strategy, the other is for short-term strategy. What do we need to do to do the time series data decomposition? The mathematical representation is like this. This is the observed data at period T. And then T is the trend component, C is the cyclical component, S is the seasonal component, and E is the random or the error component. There are two big decomposition model, additive model and multiplicative model. Additive model, we want to use this when seasonal fluctuations remain relatively constant or stable over time. So everything is adding to each other. Multiplicative is used when seasonal fluctuation increase proportionally with trend growth. So the seasonal effect expands as overall data grows. This is also called the moving average ratio decomposition method or classical decomposition. This is when the trends and the cyclical and the seasonal and the random happening affects each other by multiplicatively. So this has way more effect than the additive model. The additive model is appropriate when seasonal variation remains relatively constant over time. For example, we observe that ice cream sales always increase by approximately 20 units during summer, regardless of trend level. For example, last year we detected 20 units increase during summer. The year before also 20 units, and then the year before also 20 units. More or less, this is the average. Multiplicative model is appropriate when seasonal variation grows alongside the trend. For example, e-commerce sales increase by 20% during 8, with larger absolute increase as baseline sales grow. So for example, the baseline sale for last year is 10, and then it increased by 20% during 8. And then the next year, the baseline sale increased to 20, and then it will increase another 20% during 8. And then it happens every year when the baseline sales growth, the e-commerce sales will increase even more. So from 20% last year, it grows to 25% this year, and then the next year it's predicted to grow by 30%. This is when we do the multiplicative model. It is important for us to choose the correct model because it improves forecasting precision and strategic planning. For example, this is the additive model, a constant seasonal fluctuation. So you can see that the gap between each increase is more or less the same. But for multiplicative model, the seasonal fluctuation increase when the base also increase. So for example, if the base is lower, then the increase is also lower. If the base is higher, the increase is also higher. This is the difference between additive and multiplicative model. Now, let's talk about how do we perform decomposition. How do we change the chart from only one raw data to 3 or 4 different time series data, depending on what we want to analyze. Decomposition basically transforms raw time series data into interpretable business intelligence. And usually we use statistical tools to isolate these components effectively. The simplest approach to do this is by smoothing. It reduces short-term fluctuations and it also reveals broader data patterns. The common method is called moving average, or MA. This is a widely used smoothing method for capturing trend patterns. There are some advanced methods as well, like HV filter, X12 ARIMA, and other forecasting techniques. But as for now, we're going to start with the most common method. And when you have more interest, you can study the other advanced method on your own. You can potentially use this analysis for your final thesis, by the way. All right, so what is smoothing? Let's look at this illustration. The gray line is the original data. We see it fluctuates so much from month 0 to month 40. And then we have the smooth data, the red line, which looks pretty smooth and pretty nice. It's trending upwards, which is great. And this is called MA12, which is moving average 12, which means that we start the smoothing process from month 12 here, and we do the calculation, we do the average of the past 12 months, and it becomes the smoothing data for the current month. So this is why there are no smooth data from month 0 to month 11, because we need those data to do the MA, the moving average calculation for the month 12. And then for the month 13, we are going to use data from month 2 to month 12, and then it will move along the line, and this is what we need, what we get from the moving average calculation. It is very interesting to see that this gray line could be could also be said the same as the red, could be interpreted as the red upwards line by using the moving average method. Okay. Smoothing is an important process because time series data often fluctuates due to random variations or noise. It is a technique to use to reduce short-term fluctuations so that the main underlying pattern become clearer. We want to do smoothing to reduce the impact of short-term random fluctuations, and we want to highlight key components such as trend and cycle. The common smoothing method includes moving average, MA, and exponential smoothing, or ES, We're going to look at this later. And basically, smoothing helps transform noisy raw data into clearer business intelligence for more accurate forecasting and decision making. Now let's look at an example of the difference between these two methods, moving average, MA, and exponential smoothing, ES. This is the case study, a daily sales forecasting for a beverage product. This is the day 1 to day 30, and then this is the sales unit from 0 to 600. We have blue line for the actual data. We have green line for the moving average or MA. We have MA 7-day moving average. And we have the orange, exponential smoothing, with alpha is 0.3. Don't worry about all of these variables. We are going to explain about it later after this. Okay,